Hello, welcome to the next talk from Mesut about test automation. Four elements of successful test automation. This is a title. Mesut is going to cover common problems and fundamental solutions for test automation. So, if you're ready, the stage is yours.
Sure, thank you. So I hope my slides are on the screen and
Yes.
yes, okay. So let me get started. Hello everybody, my name is Mesut Durukal. I'm a software quality assurance automation engineer, and as a test automation or quality assurance automation engineer, today I want to talk about some basics of a successful test automation project or process. Because nowadays test automation is very important. If we are trying to verify and validate the features that we are trying to deploy to our production environments, first of all, we have to complete our testing activities. But if we don't have automation or if we don't have the proper automation, of course, we would be having a lot of troubles because automation helps us to complete our activities on time with an efficient process or activities. And if we only have manual testing activities, of course, we would not have enough resources to complete in a short time because we are racing in time, right? Time is very precious. We are developing our features and we are trying to go to the production as soon as possible because the customers and users are waiting for them. And if they are waiting too long for bugs to be resolved or maybe new features to be implemented, maybe they will already give up using our products, right? So in these terms, in terms of our product quality too, test automation is directly affecting our results or the outcomes. So we will discuss four elements, four pillars of a successful test automation, how we can manage that, how we can maintain this. So I believe most of the audience know what four elements I'm referring to. On this slide, you can see it's an ancient theory, ancient philosophy, which says that everything in the universe is composed of these four elements. So they are fire, water, air, and soil, earth. And everything in the universe is somehow composed of these four. And if we lack one of those, we cannot maintain a sustainable life. So this is the very basic idea. Like if we are missing one of those elements, then we will not be able to maintain our life. So, what we will discuss is what is these four elements in terms of successful test automation? What kind of four basic pillars we need to sustain a successful test automation lifecycle? So, on this slide, you can see a funny movie in which I guess the original movie was the Bruce Willis Fifth Element movie, and this one is a funny movie which is making fun of that original movie. And in this scenario, I guess somehow they are trying to save the planet from some other danger or some other planets or aliens, something. And somehow they are trying to combine these four elements. And again, if they cannot make one of those, then the mission would be failing. So all of these four elements are very important. And based on this analogy, let's see what these four pillars, the very important four pillars, are for our test automation lifecycle. So those would be, first of all, the mindset and the holistic testing. Because if we are talking about test automation, it is not only automating the test cases, it is not only implementation, but also doing this automation and implementation on the correct track, in the correct direction. So it will be aligning ourselves with the customer perspective, and it should be aligning our automation coverage in the correct scope. We will discuss in details. And the second one is the tooling. Like if we are talking about automation, of course, the tools, libraries, frameworks, platforms, or devices, whatever we are using in terms of the tooling are very important. If we choose or if we make some wrong choices, wrong decisions, then it might directly affect the performance of our automation because of wrong toolage. maybe we might have some not reliable test cases or very flaky test cases due to wrong tools or the libraries, or maybe we will be having some coverage gaps because the tools that we are using are not supporting the features that we need. So tooling is very important. We will discuss about that as well. The third pillar is architecture and the framework structure, some coding practices, some best coding patterns. Because if we are trying to build a test automation framework, of course, the way that we implement our test cases is very important. Like if we are building, structuring them in a framework where they can be maybe executed together with some other cases, or maybe they can be executed even independently from all the irrelevant from all the other test cases. So all these kind of dependency issues, and of course the reliability issues are very important. Because if we have some reliability issues, what does it mean? We will have to cope with these kind of failing test cases which are reporting some wrong results, right? They are not reliable, which means maybe they are reporting a failure, but it is not a correct failure, it is a false alarm. So we will these reliability issues and the test smells. And the fourth pillar is the monitoring activities and the continuous monitoring and continuous improvement. Because if we try to do a continuous maintenance, this is how it works, right? Whenever we implement a test case, it is not done. Like we cannot say that I automated this one. Okay, I'm done. I'm going to home. This is not the case. We have to continuously update, maintain our test case. Why? Because sometimes the features that the test is covering is being updated, or maybe sometimes even without feature updates, we need some refactorings to improve the efficiency or just to fix the test failures in terms of those reliability issues I just discussed. So these are the four basic fundamental pillars, those four vital elements of our successful test automation lifecycle. What happens if we don't try to maintain them? If we don't try to continuously improve them? First of all, the technical debt will rise in time, right? For example, let's suppose test cases are failing a lot. They are not reliable. So in time, whenever we implement some new features, on top of those framework that we have, the newly implemented test cases will be also flaky because we did not fix the root causes. So the test cases or the test code implemented on top of those uh, library codes or the common methods functions that we previously implemented will be also depending on those flakiness or the reliability issues. So this is the technical depth part. This is the technical side. But on the other hand, there is a psychological aspect as well. If people start that our test cases are not reliable, after some time they will start ignoring the test results, right? For example, sometimes we set up some alarms or notifications which is reporting our test cases to our Slack channels, right? I a lot of times experience that no one is seeing those notifications anymore after some time. Maybe they just mute the Slack channel because they know that it is not quite correct if the test cases are not reliable, and they just don't care even if the test cases are failing. But suppose if there is a real issue, not a false alarm, but a real bug, then even if the report is there, since people already start ignoring them, they will not be notified by a real bug alarm, right? So it is really affecting our product quality directly. So these two aspects are how these four elements are improving our processes. So it's important to continuously maintain them. If we do not continuously take an eye on them, then all the technical depth and the other aspects of quality will all increase in time. So let's try to see them in detail one by one, starting with the first pillar, which was the mindset, right? How the automation is related with mindset. Let me explain you. For example, let's say that I have 100% automation. Does it mean that everything is cool? Maybe not, right? Because maybe the test suite is not complete. Like, okay, all the defined test cases are automated, so automation coverage is 100%. But how about the test coverage itself? Like maybe the test cases were not defined properly in the first place. So even if you try to automate all of them, by the way, 100% automation should not be our ultimate goal, right? Sometimes you might uh, choose not to automate some of them, depending on the criticality, depending on the frequency that you execute, or even depending on the difficulty. Like you don't have to 100% automate all the test cases. But even if you do, sometimes it doesn't mean that the everything is done in terms of quality assurance. So we have to ensure that the test scope, the test coverage is correct. And then if we have some test coverage or coverage gaps, we might try to understand the root causes. Most of the time, it might mean that we have some testability issues, because somehow there are some features, but they might not be testable due to some reasons. It might be like the nature of the product. For example, it might be a microservices product, and they are maybe working asynchronously, so we might have some timing issues. For example, sometimes for some feature they are working overnight, right? For example, the users are doing something, and some reporting features are collecting these actions, user actions, cumulatively, and after one whole day, then we can see the reports. But think about that, how can I verify this feature? Because first of all, I will do a user action, and then the analysis feature will collect all the results for a day, and then I can see the result after one whole day, 24 hours. So this is a testability issue, right? Of course, there might be some workarounds, like maybe I can already generate some user actions with the previous times, and I can try to see the result. But this is just an example. So you know what I mean. There might be some testability issues stemming from different reasons. It might be timing issue, or it might be any other technical issue. So what we can do is we can collaborate on them with developers or product owners, quality assurance members, so everyone in the team, all the parties in the project, and do a holistic testing approach. Let's do a brainstorming and how we can cope with these testability issues, how we can try to pave the way for testability, what kind of additional features we can implement to uh, generate an environment where I can test these products, because previously they were not due to some reasons. So we can find some solutions, but of course, it is possible with a whole team approach. If we are trying to ensure the quality only with individuals, only in the quality assurance teams, it will not work. It will not be possible. And again, we will, of course, talk about this. Our test cases reliable. For example, we might automate, again, let's say 100% automation is done, succeeded, but are they reliable? For example, I automated all of them and I executed, but how about the results? So these are the aspects that we should keep in mind and try to continuously keep an eye on to ensure the reliability of our activities. For example, let me a little bit further go into the customer perspective, because we are saying like maybe we might automate all the test cases, but they might not be the correct scope, right? What I mean by this, for example, I'm sure most of the people know this famous cartoon. It's funny, but it's quite correct most of the time. Like we can see sometimes the product owner or the project manager understands in the wrong way what the client or the customer is explaining. And most of the time, the customer himself does not know what he needs. And then, after those kind of requirements or the specifications, a development is done, which is again maybe totally different. And then we test in a way based on the documentation we have, which is most of the time no documentation at all. And of course, it will be way different than what the customer needs. So he needs something, he or she needs some features, and then they explain in a different way, and then it is developed in a different way. So how can I be verified or validated? So having the customer focus, looking to product from the customer perspective is very important. So what can I do as a quality assurance member? Like if I'm talking only with the product owner, then I might have a limited perspective. But sometimes I may try to find ways to communicate with the end users as well, to understand what kind of use cases they have, or what kind of features or extra implementation they need. So in these terms, I can raise some bug reports or maybe some change requests. In terms of the bugs, for example, it will be very costly or expensive whenever we cannot find them on time, right? Because if I don't have the customer experience or customer perspective, then I will already let the features go in production. I will already let the deployment, but the end users themselves will start reporting these bugs. So what's the problem about this? Eventually, if we have these bug reports, we can solve, right? Yes, we can solve, but it will be way more expensive than catching on time before going production. Because if the product is already in the environment, then it will be very difficult to apply those fixes on working features. Maybe refactoring will be very difficult since the feature is already there. So what we can do is we can think again from the end user's perspective. So on this slide, we can see, for example, those guys are trying to cross the small river, right? So what is meant in the story is, as testers and developers, we will be using these tools or these features that we already implemented previously a lot of times. So we are familiar and we know how to use it. But for the customer or for the end user, it is not the case. It will be the first time they are using this, so they can fail because they are not expert on using this, which means maybe we might widen our perspective to think more about the usability, to think more about how the documentation is done, how the accessibility is achieved. So all these kind of quality aspects we can already keep in mind if we have the customer perspective. So one approach which can help us to improve a customer perspective is personalized testing. For example, if we think about different characters which might, or different profiles which might use our system, it can really help us to think about different scenarios. For example, some profiles have some different strengths or different weaknesses, or maybe they have different priorities. For some of them, maybe as accessibility issues are very important, but for some others, performance is super important, for example. So for every other profile or persona, like the different characters which might use our system, a different aspect of the quality might be important. So it will help us to improve our perspective and think from different aspects of the quality. So I advise using the persona-based testing if we have different categories or profiles who are using our systems or features. Let's move on. In terms of mindset, of course, not only the customer perspective, but also the collaboration within the team is also very important. For example, most of the time we are doing some testing activities in different levels, right? We have the unit test cases, we have the integration tests, and then we have maybe the system acceptance or end-to-end tests. So we have different levels. But if there are some duplication, which means some feature is already tested in unit level, and we are trying to test it again in the end-to-end level, so it is not super efficient, right? We have some duplication. But why don't we try to prioritize the features which are not tested yet, instead of the features which are already tested a lot of times in the unit test or integration tests? So this means we need a decent collaboration and communication within the team. Like if I don't have any connection with the developers, I cannot know what unit test they have. Or sometimes I cannot get support, get help from them, right? Or like in the other way around, sometimes they need my help, the development team. Sometimes they ask some questions to the quality assurance team. Sometimes they need the quality coach perspective. So if we don't have this communication or connection, then of course it will directly affect the performance and the efficiency of our collaboration within the team. Because again, I'm going back to the first point that I raised. We are on the same boat. If we are trying to ensure the quality individually by only the members in the quality assurance team, it won't work. We have to work all together as a holistic approach. So I'm moving forward to the second pillar. The first one was the mindset, the customer perspective, and the collaboration within the team. How about the second one? This is a little bit more technical part. So we will talk about the tooling that we can use while building our test framework. So on this slide, this is me, but a little bit confused me because there are too many options we can use, right? For example, whenever you are starting a new test automation project, which programming language do you use? Is it Java? Is it JavaScript, Python? Which one is the best? Or let's suppose you decide JavaScript because most of the time you are doing front-end automation, web application automation. Then what is the best framework you can use? Is it Cypress? Is it Playwright, Test Cafe, or Selenium, or anything else? So obviously the answer is there is no clear answer, right? There is no single correct answer. There might be several different options, and we should choose the correct one. For example, if I choose a tool which does not support what I need, then of course, obviously, it is not the correct decision. But how can we make this decision? Of course, there are different decision criteria, like the speed, execution speed. Some tools are slower than others. Some of them are faster than others. Ease of coding. Some of them are easy to implement, but some of them are working asynchronously. So you have to create manually some promises and wait for the responses properly and then continue to the next steps. But in some of them, you basically put just await keyword at the beginning of the line and that's it. So some of them are super easier than others. Flexibility, like some of them, you can easily capture the request and intercept the request that you are sending to the servers, and you can easily manipulate what you are trying to do. Those have those flexibilities to modify your test steps. Some of them have decent documentation and community support, while some of them lack documentation. And of course, in some of them, some features are paid services, while some others are totally free. So these kind of things are different decision criteria. You can choose whatever is important for you. For example, if you say that, I don't mind what features they are supporting. I'm testing a very easy, very simple product. So only very basic elements, components are enough for me. I never work with cross-domain issues. I never execute my test case on a mobile device, only executing on Chrome and only finding very basic components are enough for me. So if this is the case, maybe you might choose the speed, like which one is fast, then go with it. But otherwise, if in your application what you are testing has some complex and complicated features, then you might search for the one which supports those features, which can be implemented easily. So the decision criteria might depend. But please beware of your requirements and then try to make the choice based on those requirements. So there is no clear answer. For me, Playwright might be the best tool, but for you, Cypress might be the best one. For another person, Selenium might be the best one. So please define your requirements and do an analysis to understand which one is covering those requirements. But just as a reference, of course, you can do a literature survey to see what other people are using. Or maybe to see which trends are in the marketplace nowadays. Like, for example, this graph, I took it just today. And we can show that the download rates over npm repositories for the major test frameworks like Cypress, Nightwatch, Playwright, Puppeteer, Selenium, Test Cafe, and WebDriver IO are here. And we can show that uh, on Playwright, which is the green line, there's a decent increase nowadays, right? This is the last 1 year graph. So we can see how from where it started, now it is one of the most downloaded one with Cypress too. Cypress has some stability for some time because some time ago it was the mostly downloaded, the most commonly used one. But nowadays we can say that Cypress is not the only one anymore, but sharing the first place with Playwright. So again, this is just a reference, but your choice might be a different one. But what I advise you is to have a developer experience. What it means is, whenever you do this analysis, please try all these kind of options and try to implement some test cases with all these options. So this is what I did. On this screenshot, you can see some implementation I have done with all these options. This was for a benchmark study. And I picked one test scenario, which was a easy test scenario. And I just tried to implement with all options to see what kind of uh, bottlenecks or the difficulties I have while using different options. And of course, eventually I measured the execution speed for each of them. Like 100 times I executed with all options, and I measured the average execution duration on different platforms. Like what happens if I execute locally? What happens if I push to my CI/CD platform and I execute on the remote machines too? So all this kind of analysis you can do, and you can choose the best which is serving to your goals. And this is just a functionality matrix, like which functions are supported by each option. So this second part was basically the tooling where you might need a benchmark study to choose the best option, because again, there are too many options, starting from the programming language as well. Even starting from there, how can you choose the program language? Sometimes you try to align yourself, the quality assurance team, to the development team, because to increase the collaboration, sometimes you may want to use the same language, but not necessarily, right? Whenever the developer teams are using another language, you can use another one. You can go with another one. But you can choose the same too, depending on the team structures or the other decision criteria. But just list your requirements and try to understand which one is best for you. Because if you ask me what is the best tool, testing tool, there's no clear answer for that. It depends. As always, right? The answer that we like the most is it depends. Element number 3 for us, for maintainable, successful test automation lifecycle: the design practices, the implementation coding approaches. And for this, I will mostly highlight the importance of the duplication. Whenever we have some duplicated code, then it will result in some trouble or some critical refactoring or maintenance issues. So let's see how they affect our test implementation and the maintenance efficiency. So I want to share you a concrete example from real life scenario. For example, on this slide, we can see different headers in our web applications. So I'm working for a job seeking platform. So the users can go navigate to these web applications and search for some jobs. They, for example, put a keyword like software quality assurance engineer, and they put a location like find the jobs in Berlin, find the jobs in London. For these kind of queries they can make. But there are 3 different web applications we have. All the targets are different. For example, one is for the part-time jobs, the other is for a different target people, like for engineers, and the other is for the healthcare people, for example. But we all have the same header, because sometimes you might realize this is the case, right? In your development teams, there's a UI UX team. They are developing these kind of common frameworks or components, and then they share with different development teams so that they can use in their applications. So how does this relate with testing activities? If these kind of common UI UX teams are developing common frameworks, then as the testing team, we can also develop a common test code. For example, when I'm testing these 3 different web applications, normally I have 3 separate repositories where I keep my test code. But if I rewrite the same code again from scratch in these 3 different repositories, it is duplication, right? So I'm doing the same implementation from scratch again and again while it was already written in the other repository. So it is not only the duplication of the effort because I'm trying to implement from scratch, but also it results in some maintenance issues as well. For example, whenever there's a duplicated code and whenever I have to fix something on this piece of code, what should I do? I go to each point where this code is used and I have to fix, right? But if I already use only one single library where I have this code and I use this single library as a dependency in all these 3 different repositories, then what I should do is just go to the relevant library and do the fix on a single point, not go to each repository and fix one by one because I did not duplicate. I just used one single code and I reused in multiple places. So the key point here is while implementing our test code, please try to make them reusable. Please try to execute all the parameters or the user options arguments from the test code itself. You don't have to write everything in the test spec files. Try to use helper methods, helper functions, and try to exclude the common steps into some separate designated classes. In this way, you will be reducing the duplication and the maintenance activities, the refactoring activities will be way easier than before. For example, at what times do we need these kind of refactoring or maybe fix activities? For a while, I'm referring to false alarms, right? What does it mean? It means, for example, whenever we have a failure in the test cases, whenever the test report is fail, but normally when the feature was working properly, when there was no real bug, it means it's a false alarm because test case is reporting a bug, reporting a failure, but it is not a bug. It's a false alarm. On the other hand, if test case is passing, which means it does not report a failure, but if there is a bug in the feature at this situation, it means test case is not capable of finding the bug because it's not reporting anything, it is just passing. But there is an issue in the feature. So it's a silent horror case. So these 2 cases are the issues which might result in some critical consequences in the later stages, like the escape bugs. What kind of reasons may result in this kind of test smells? There might be several different reasons. For example, there might be asynchronous waits, or there might be extra load, or maybe some objects which are created which were supposed to be cleaned up after the execution, but which were not. So they might be resulting in some conflicts since the objects are already there before creating again. Or there might be several reasons. So I will not list all of them, but I will just warn you to be aware of these kind of test smells. There might be lots of different categories of potential reasons for the test smells. And of course, there are different solutions to cope with this kind of root causes. Please try to understand why your test cases are failing or maybe not failing while they were supposed to, and try to resolve all these kind of root causes. Let me share you one example from my project again. It's a practical example from real life. So what we tried to do is, it was the case, the product that we were testing was a microservices architecture product, and there were some asynchronity issues. So I needed some retry mechanism in the test cases because once you query for the expected result, it might not be there. But if you poll, periodically check until the last accepted timeout, then you might have the correct answer. So I did a benchmark study like what happens if I do not implement this retry mechanism, smart polling algorithm, but what happens when I add this additional supportive implementation to my test code. So you can see easily how your preventive actions are contributing to your reliability. On the left hand side, you can see there is too many failures, but on the right hand side, there's only once. Maybe it is really the product issue. Maybe it did not respond in time. So by this kind of continuous monitoring activities, you can see how your actions are helping you to cope with the test smells. So third pillar was building the architecture in a proper way by trying to remove the duplication and trying to encourage using reusable test implementation and test code. Now the fourth pillar, the fourth element for our test automation environment, which is the continuous maintenance, which is very directly relevant with the continuous monitoring activities. So why do we need that? Why do we have to do, or why would we do continuous monitoring? Because it might help us to evaluate our current situation, like how much progress we have already made or how much more we have to reach to our goals. So this is the current evaluation. But with a future estimation, like if we go with the same pace, what percentage will be remaining? So these kind of future estimations too we can do. So these kind of monitoring activities help us from two different dimensions. And whenever we try to do this main monitoring activities, of course we will be collecting some metrics, right? But what kind of metrics we can collect? There are too many metrics we can collect. Like on the slide I have maybe, I guess, around 30 40 metrics, but which one should we choose? Again, the answer is depends, right? Because you have to again prioritize your needs and list all the metrics which should be or could be useful to represent these priorities or the requirements. And then after listing all these metrics, you might have to modify your execution environments or the implementation environments. Because sometimes whenever some project issue or the issue tracking systems you are using, if you go with the default workflows, it is not visible enough. Like there are only 3 4 state transition diagrams, and it is not enough, but you can modify it to eat additional steps, additional transitions, and it will be much more visible on which specific stage you are spending time, or on which specific transition, for example, from an implemented task to execute it, maybe you are spending too much time. It means why don't you start executing after just it is implemented, right? So you can try to understand the root cause for this kind of waste of times. So for a better visibility, for a better transparency, please consider modifying the default workflows. And then, of course, doing monitoring manually is an option, but you can do automated monitoring as well. Like try to build some code and try to execute them within a pipeline, within a job, automated job, scheduled job. So you can already collect these metrics by sending these queries automatically over the code. So these are some best practices for doing the monitoring activities, right? Define some metrics and do the automation and modify your environment. And then after collect all these metrics, numbers are great. They will be explaining us a lot. We can collect several insights from them. But reading the raw numbers is not easy all the time. So what we can do? We can transform these numbers into some visuals, right? If we use some dashboards or maybe monitoring graphs, charts, it will be way easier to understand visually. We can see how the trends are increasing, decreasing, or the distribution of different charts. Let me again give an example from my real life project. For example, this is a chart where we can see distribution of bugs across different dimensions. For example, across the distribution across their status. What percentage of bugs are still open and what percentage are still closed or still waiting to be closed? Or the percentage across their criticality or the priority. Like most of them are severe bugs or less severity bugs. So you can see the percentage of different severity levels too. And not only the bugs or the historical data, but also you can collect data from the production environment too. For example, at what times is the application responding slowly? Maybe, for example, in the midnights, maybe my web application is very slow. The response time is very high. So these kind of insights I can collect, and after I collect these kind of insights, I can try to improve them by building some strong quality gates, right? If we do not stop the risks or the threats in the first place, if we just let them go, then we will have those troubles in the later stages, which will be again more expensive, more difficult to fix in production environments. So it is better to stop them in the first place by some strong quality gates. So I'm wrapping up. We went over 4 different pillars, 4 different elements of successful test automation lifecycle, which were basically the mindset and the customer perspective and the holistic testing, trying to improve the testability issues, trying to make a collaboration with the development team and product team and the quality assurance team. And then we discussed about tooling, doing a benchmarking uh, tool benchmarking, and then uh, making the correct choice. And then we discussed about having the test reliability, which is depending on the architecture and the approach or the patterns that we are following to implement our test cases. And finally, we discussed about continuous monitoring to collect some different metrics and try to get some insights about our progress, right? How much coverage we have, how much or how many bugs we have. Of course, only some specific numbers will not be helpful. So, monitoring should be implemented in a comprehensive way, in a smart way. If you just count the number of bugs, I have 20 bugs, I have 30 bugs, so what? It doesn't mean too much, right? So you have to collect the historical data, and you have to do comprehensively analyze this historical data. So thanks a lot for listening to me. And if you have any questions, please do not hesitate to reach out. And if I have time, I guess I'll try to.
Yes, thank you for your talk. We have very few time left, but may I ask a couple of questions?
Sure.
First of all, about flaky tests. You mentioned it like common tools to mitigate flaky tests, like introduce retrying and so on, but they don't always help. So what
Yes.
should we do if you have flaky test, and retrying doesn't work? So what?
Yes. So every flakiness should have a reason. Like in my case, it was the asynchronous wait. So I tried to add some retries. But in some other cases, the root cause for the flakiness might be something different. Like it might be the structure of the web page, like if some components are not loaded on time or anything else. So depending on the root cause, there might be a different solution. It is not always adding some retries, but applying the correct fix would help to cope with the test smells.
Sure, but sometimes we just cannot find the solution. Cannot detect what is the root cause. Like
I mean, if we apply the correct monitoring, we should be able to find the result, the reason or the solution. But if we not, there might be some alternative ways, like we can do parallel testing. So if in any of those pipelines, if the test is passing, then we can take that into account. I think that might be the worst case.
okay, and probably the last question: how to test microservices? I mean, like a complex system composed of multiple microservices, which are hard to
Yes.
monitor altogether. And
Yes.
even if you do monitor them, it's hard to combine all this data together and understand
Yes.
what happens here.
Exactly. Since due to this fact that sometimes it is difficult to collect everything into a single platform, contract testing is a very commonly used approach for doing the microservices testing, because in this way you can test the microservices isolated from the others, because you know the contract, how it should communicate with the other services. So in these terms, you can apply the integration test and then eventually collect the whole system into a single platform.
Okay, so I suggest to test every microservice independently. It's absolutely good idea, but
Yeah.
often people say that no, we want to test the entire system.
Yeah, but this is why we have a test pyramid, right? You start with the integration test or even the unit test, and eventually you have the system test where all the components are all together.
Okay, thank you. I think we have finished with questions, and yeah, thank you for your talk.
Sure.
I guess here we will have some lunch break, probably about an hour, and see you after the lunch. Yeah, thank you very much.
For you. Thank you.